We're going to discuss arithmetic sequences. These are the sequences where you add the same number between terms. And what if you needed to know a very large term? If you needed to know the 100th term, you wouldn't want to add your common difference 99 times. Well, we have a shortcut for that in a formula. And so we're going to begin with T sub n. That means the nth term. And we will begin with the first term, and we're going to add it. So we'll have d times n minus 1. And that's the number of times that we would add the difference to get to the nth term. So, I want to find the nth term of the arithmetic sequence 7, 11, 15, and 19. Well, this is a general equation. Nth means we're not looking for a specific one, so we're going to be leaving n in the equation. Well, let's label what we need. We need the first term, and that's 7. And we need the common difference, and if we subtract 7 and 11, that's 4. And that's enough information for our formula. So we'll just substitute what we know. Okay. Now, we want to simplify this a little bit. So, let's multiply the 4 through the parentheses. Distribute that, and then we will combine our like terms. And that gives us the equation for any term in this particular arithmetic sequence. Now, I want to find the 11th term, and I believe this is what we had. 4n minus 3, and we will define the 11th term right here. That means n equals 11. So we'll have t sub 11 equals 4 times 11 minus 3, and so we'll have 44 minus 3, and that's 41. So basically this means if we start with our first term of 7 and we add 4 to it 11 times, or 10 times, we will get the 11th term, which is 41. Now our next example, I want to find the 20th term for this arithmetic sequence, but I don't have the first term. So what we're going to do is use a system of equations. And so just as a reminder, I'm going to write our formula right up here. Now what we do know is we know 3 different values for n. We know 2 and 5. We also know the value for the term itself, but what we need to find in order to be able to solve this is the first term and the difference. So we're going to set this up as a system of equations, and we're going to start with T2, and T2 is 13, so this is going to go on this side. And we need to find the first term, and n is 2, so 2 minus 1. Let's clean that up a little bit. 2 minus 1 times d. That means the right side of my equation is T1 plus d. Okay, easy enough. And then we'll do the same thing with T5. Well, T5 is 22. We still need to know the first term. And if I substitute 5 into the formula, that gives me a 4, so 40. Now, I can actually add these together to solve for my distance. So I'm going to change the sign on my top equation, make that negative 13, negative t1 minus d, and add those together. And this gives me 9 equals 3d. So my difference is 3. So that's what we need. That's one of them. So the second thing we need to find is t1, and it's going to be easiest to use the first equation for that. So we'll have 13 equals t1. And the d ended up being 3. So that means t1, our first term, is 10. So we know now we have our first term and our difference, we can solve for t20, the 20th term. Now remember, n is always given to you. N is right here. And so we will substitute into that. So we'll have t1, first term is 10. Now n minus 1, n is 20, 19. And our difference is 3. And so our 20th term is 10 plus 48. Nope, 57. And so our 20th term is 67. So sometimes you have to use this formula twice and set it up as a system of equations to be able to solve it. Now, example 4. We want to find the 17th term. This time, I do have my first term. There's my first term. And my difference is 5 minus 2, so the difference is 3. So we're good there. So the 17th term is equal to the first term plus the n minus 1, so it's 17 minus 1, so that's 16. And then times 3. So that's 2 plus, here's where the 48 is, plus 48, and that is 50. Okay, the last problem. How many terms are in the sequence? How many terms? So that means we're going to find n. Okay, we know this is t1. We know that d is 5. And we know this is the last term, and we don't know what n is. So we want to know how many terms are in the sequence. So let's substitute n. So we're going to have, here's a formula as a reminder. So we'll substitute in our last term that we know, which is 350. We just don't know which position it is. And we're going to substitute our first term. And we don't know what n is, so we're going to leave it. But we do know that the difference is 5. So we should really distribute that 5 through the parentheses. So 5 plus 5n minus 5. And that means 350 is equal to 5n. And we divide both sides by 5. And that means we have 70 equals n. So this is the 70th position, so what we can say is that T70 is equal to 350.